Hi there, this is Azul Maksud. I am back with another very much important one, real-time interview crackers, part 14.2. Already I have made part 14.1. So this is for the second part of AWS for freshers and experienced. Especially for freshers, this is, but also this is important for experienced. AWS engineers day-to-day issues in the real time. Whatever I have faced, I just accumulated. I have lots of documentations I have taken from there. For this second part, 6 questions and 15 scenarios. Guys, very much important 15 scenarios. And I am adding this one here. Here DevOps Q&A in my GitHub repo. And here it was earlier DevOps Q&A 14.1. AWS freshers and expert. I'm taking everything from here. Control A, Control C. I'm doing now because sometimes I forgot. Then some viewers becomes very much angry. It's normal. So I'm doing right now, man. Too much job, honestly. So here is commit changes. Yeah, guys. So this is 14.2 here. You can come here if you like. Also in my YouTube channel, if you follow my playlist, especially interview crackers, AWS troubleshooting, Kubernetes, Python, CI/CD, another one, AWS DevOps job ready project. If you follow these guys, I believe you will be very much quickly AWS DevOps engineer. Hope to see you like that. Okay, let's go to the in detail. How do you secure your DevOps pipeline, especially with secret management techniques? So this is really very much important. Repository stage, build stage, then image security, then deployment, post deployment. So here is repository stage. I use Git hooks to detect sensitive information before committing code. Then build stage, static application security test. That means SAST, static application, SA, security, S, then test. SAST helps scan for vulnerabilities in static code. SonarQube we are using vastly. Then image security. After building Docker images, I scan for vulnerabilities using tools like Trivy. Then deployment, dynamic application security testing DAST. So this is the DAST coming. Then it ensures secure runtime environment. So DAST ensures secure runtime, man. This important word, I'm making this red. Then post deployment, continuous monitoring with Prometheus and Grafana helps detect and respond to security issues in real time. Then what is the difference between SAST and DAST? SAST already you know, static application security testing, then analyzes source code for vulnerabilities before the application is deployed. Example, detecting unused imports in Python or identifying hard-coded secrets. DAST, dynamic application security test, scans the application in a running environment. Example, detecting open ports or vulnerabilities that can be exploited in a production environment, such as 404 errors. So yeah, this kinds of thing for 404 we know that not found actually. The front end and back end not connected is showing like that. Then can you give an example of how you have automated infrastructure deployment using Ansible? I used Ansible for configuration management after creating EC2 instances with Terraform. So configuration management playbook example, installing Nginx on EC2 instances automatically. Then handlers, I used handlers to restart services whenever configuration changes are made. So playbook example is that I have installed nginx on EC2 instances, all the EC2 instances, how many, 100, 200, 500, either way, using instance automatically using which one, Ansible. Okay, then handlers, I used handlers to restart services. Then what differentiates Ansible from other configuration management tools like Chef and Puppet? Ansible is agentless. This is the very beautiful word. Please memorize. When Ansible is agentless, that means Chef and Puppet is agentful. That means they need the agent. Ansible uses SSH for communication, making it lightweight and easy to use. Chef and Puppet requires agents and master nodes, which add complexity, but can be more powerful for larger scale environment. Okay, yes, larger scale environment can be more powerful, that's true, but in general Ansible is much better. I prefer Ansible. Then what's the difference between a pod and a container in Kubernetes? A container runs an application and its dependencies in isolation. So container runs, actually when think that container is the application, always I think like that, one container, one application. Okay, and it's and the dependencies in isolation, and it likes the isolated, that's microservices like that. A pod is a higher level abstraction in Kubernetes that can contain one or more containers. Pod is the higher level abstraction. So a pod can have lots of containers. Normally one pod, one container. Then example, a pod running an nginx server alongside a logging container. Then can you walk us through a Kubernetes deployment issues you resolved? Sure, you can say like that. During a production deployment, please memorize, Kubernetes is very much cost effective, honestly. I know about the EKS-CTL, that means Amazon Elastic Kubernetes Service. So this is very much cost effective, so this is used especially for the production deployment. The application pods kept restarting. Root cause: insufficient memory allocation in the pod resource limits. So yes, this is the root cause, insufficient memory. That means memory is the low, not more. It should be more, but it's now right now is low. So in the pod resource limits, then I adjusted the resource requests and limits in the YAML manifest and scaled up the nodes in the EKS cluster. Scenario 1, now we are in the scenario. Okay, which one? The troubleshooting failed Kubernetes pod. I'm changing the color, that's good, right? Okay, I'm changing this color. Okay, so troubleshooting a failed Kubernetes pod, failed one. A pod in your Kubernetes cluster is stuck in crash loop back off. Okay, it's just running in the street or highway, crashed. So why crashed? I think like that. How would you troubleshoot and resolve this issue? Guys, please keep your concentration here. Learn one time, use lifetime. I like this method. Why I'm saying I could not learn one day, honestly. Lots of even years I have to spend these kinds of problems to learn. Check pod logs. You have to check the pod logs. How to keep CTL logs first, then the pod name, then you can do the previous like that, either way, or name server, which one you have. So pod logs, previous, that's good. Analyze the logs for errors such as missing environment variables or application specific issues. So environment variables are important, which is missing or not. Then describe the pod. So kubectl describe and kubectl logs. These guys are brothers, honestly. I think almost every time I have to see logs and describe all together. So describe pod and kubectl logs. This is the command sometimes making mistake with me. I hope you guys are smarter than I. So kubectl logs, kubectl describe, but after describe the pod, then the pod name. Okay, this is the complicacy with me sometimes. Look for events related to image pooling. So image pooling, you have to see that image pooling is done or not. So question is here, cache loop backup, right? So image pooling, you have to see resource limit. So cache loop backup, vastly the resource. The problem is resource. When the resource coming, then CPU and memory is coming. Keep in mind, please. These two guys too much. CPU and memory. And configuration errors. Also the configuration you have to see. Common solutions. Verify environment variables are correctly set in the deployment spec. Ensure the Docker image is available and accessible. So first of all, the environment you have to see first. Then Docker image you have to see is available and accessible. Increase resource requests or limits of OOM killed. Out of memory, OOM killed. This is the out of memory. If the OOM killed errors are found. So if out of memory is found, that means increase your resource. See here, resource when coming, then coming the word like CPU and memory. See here, memory is killed, out of memory. That means increase. If CPU is 5, make it 10. If memory is 50, make it 60, like that. Check for compatibility between the application and Kubernetes version. Also version too much problems. Best practice, use readiness and liveness probes to monitor pod health. So best practice is readiness and liveness probe. So if you use this one to monitor the pod health, that is good. So this is for why? This is for especially the problems with this one, crash loop back off. So when you are using the readiness and liveness probe, then there's the time. Readiness needs some time. You have to mention the other time. Also the liveliness. So readiness is happen only one time, but liveliness too much time. Liveliness means when lively, that means deadliness. Okay, when pod is dead, that means you have to make live. So how much time is taking to be live? So this is you have to see. Then secrets, scenario 2, secrets management in DevSecOps pipeline. How do you securely manage secrets in a DevOps pipeline? Using HashiCorp Vault. Okay, setup, install and configure HashiCorp Vault on a secure Bastion server. Configure HashiCorp Vault on a secure Bastion server. Then Kubernetes integration. Create a Kubernetes service account, SA service account, and role binding for Vault authentication. So first of all, you have to install HashiCorp Vault on a Bastion server. Then the service account you have to create and role binding for Vault authentication. Then use Vault agent injector to inject secrets into pod environment. Then so keep in mind that service account Vault agent injector, actually keep in mind the agent. Okay, and this is the injector. There's the too much coming, the injection is doing the pushing the injection, the secret, inject secrets, okay, into pod environment. So secret in the pod environment, keep in mind, this is not in the container. Pod environment, the secret is injecting. Just keep in mind about the HashiCorp Vault. I am creating service account and binding the role binding for Vault authentication. Service account authentication. That's why I have created the service account with authentication. Then agent injector to inject secrets into pod environment, and I'm injecting secrets into pod environment. Just say the pod. I'm injecting the secrets into pod. Finish, man. Very easy. Just keep in mind that service account I have created with authentication and with agent injector. I have injected the secret inside the pod. If my face is pod, then injecting the secrets. That secrets which one? Username, password. These two things just keep in mind. Username and password I have injected into the pod environment. Finish, man. Then automation, define vault policies and roles, access secrets using dynamic database roles for secure backend communication. Security best practices, enable auditing in vault, rotate secrets regularly. So when a secret is coming this word, then always coming the rotation. Is coming the word like, have you rotated? Yes, I have rotated the secret, because after 30 days or 3 months, you must have to rotate the secrets like that. Then scenario 3, zero downtime and deployment on AWS. Zero downtime. How would you change the instance type of a production EC2 instance without any downtime? Create an AMI from existing instance. You have to create the AMI, machine image, from existing instance. Then so existing instance, that means instance maybe for front-end, back-end, or database server. You have to create that AMI machine image. So how to create? If the CLI, then AWS EC2 create image. This is the basic thing. Then instance ID. Then instance ID, you have to write here name, then the name coming. So in the interview you can say AWS EC2 create image. Then I have used the instance ID. Finish. Then launch a new instance with the desired instance type. Attach the existing elastic IP and security group to new instance. DNS update. Update Route 53 DNS records to point to the new instance type. So okay, interesting thing is that you did everything, but Route 53, the DNS record, you did not update it to point the new instance IP. DNS record means actually a record. I have to write here, then it should be better with you guys. So a record for IPv4, and for a that means for a records for IPv6. So a record, keep in mind, a record updated. I have updated the DNS update. I have updated a record in the Route 53 for new instance IP. Validation. Test the application thoroughly after the instance switch. Test the application thoroughly after the instance switch. Then scenario number 4, Jenkins pipeline failure diagnosis. Oh my goodness, too much is coming. A Jenkins pipeline fails intermittently when building Docker images. How do you troubleshoot this? Jenkins pipeline fails intermittently when building Docker images. So intermittently means now and then, like that, to and fro. So yes, it's coming off, on, off, on, off. So how do you troubleshoot that? Check Jenkins logs. Of course, logs you have to see first. Console log you have to be. Then analyze the Jenkins master and agent logs for resource related issues. Resource allocation. Increase memory or CPU limits for the Jenkins agent. See here, when intermittently coming, so intermittently when coming, most of the cases, the problem with resources, CPU and memory, the problem. It's not only for Jenkins, for the freshers I am saying actually. It's not only for the Jenkins, it's also for the EC2 servers. Is coming the problem like intermittently on and off. Then please see the memory, CPU and memory, both guys you have to see. You have to increase that. increase. I'm making the color this one. Limits, increase. Which are the limits for? Here is the Jenkins agent. Jenkins agent is here. You can feel like EC2. So EC2, if the Jenkins agent, then CPU memory you have to increase. Then Docker cleanup. So Docker system prune -af. Then clean up unused Docker images and volumes. So you have to clean up after system prune AF. Watching that, then you have to say clean up the unused. Error handling, add retry logic in pipeline steps for network related errors. Use Docker build -no cache to avoid image layer corruption. So use Docker build -no cache. I'm changing the color to avoid image layer corruption. Very important. Sometimes the Docker image is corrupted. So to avoid this, the no cache, that means cache memory should not be there. Then scenario 5, automating Terraform and Ansible workflow. How do you automate provisioning and configuration using Terraform and Ansible together? Very interesting thing. Terraform and Ansible together, provisioning and configuration. So how do you do that? Provision infrastructure with Terraform. Use Terraform to create AWS resources such as VPCs and EC2 instances. So when creating this, then export inventory for Ansible. Terraform output JSON Ansible inventory. Then inside this one. So Terraform output is here in the JSON format. Then should be just put like this way. Terraform output command. Then which one? The language JSON. Then Ansible inventory _inventory. Then it should be stored. See here, this arrow means stored. This is the shell system. So inventory.json, this is the variable name. You can change this name. So everything Terraform output in the JSON format, in the Ansible inventory, it will be put, everything is here. So this is the export inventory of Ansible. How to export the inventory of Ansible? Then configure with Ansible. Use the dynamic inventory file to target newly created resources. So configure the Ansible. Name, install Nginx on EC2. I like this kind. In the name, how do you do? You can write and Ansible reading this one. Ansible doing. If you say Ansible, please install this one. Install Nginx on EC2. It's working. It's reading. Human readable is called. Hosts, all the hosts. How many hosts? Every host if you like. Then tasks, name, install Nginx. apt name, Nginx state present. So here is the after having the name, that means what kinds of job, then how many hosts, all or not, then you have to have the task, name, host, task. Please keep in mind these three guys. Okay, why I'm saying, I forgot sometimes. Name is followed by hosts, host is followed by tasks. Freshers, I am targeting the fresher guys. Whatever I have passed in my to learn, too much time I have taken this one. Honestly, I believe you guys are smarter than I. So name, host, tasks. So tasks can be lots of tasks, 100 tasks, 200 tasks, does not matter. But inside the task, if task is parent, that means father, parent, then the name is child. So 100 task, every task starts with a name. This name under this task, not this name. Okay, so this is why inventory files the task here. So here is the under this task name, install Nginx is coming again. See here, you said here install Nginx on EC2. Now the task you will just reconfirming or specifying install Nginx. apt for Ubuntu command, apt name, name equal, that means assign, not equal, is assign nginx state. So nginx state should be present. So something tricky I'm saying, making some space here. So when this is the this is called a task job, when you are creating inside the inventory file. So if you say do something, install something, the one is will be end at the present state present. That means after installing, state should be present. Then our automation best practices, use Terraform remote state with AWS S3 and DynamoDB locking. So the best practices is which one? The remote state with AWS S3 and DynamoDB locking. This is very good. Integrate Ansible playbooks in Jenkins for post-deployment configuration. So this is the thing. Always S3 DynamoDB locking is very much good. And integrate Ansible playbook in Jenkins for post-deployment configuration. And scenario 6. Come here, please. This is the AWS Lambda timeout issue. Real-time problem. This is Lambda timeout. Okay, I'm making this is Angular. So your AWS Lambda function to stop EC2 instance times out after 3 seconds. How do you resolve this? Increase the timeout. Modify the Lambda timeout settings to a higher value, 30 seconds. Actually, I'm giving 59 seconds. I like this one, 59 seconds. Lambda takes too much time if needed, because sometimes the network is issues. Okay, 30 seconds is industry practice this is, but my practice is 59 seconds. I'm giving more times. Then this is in the actually Lambda configuration. If you go to the Lambda configuration, let's see the Lambda configuration. I think the Lambda is here. Yes, let's go there. Let's see here, e-commerce. I have one. So if you go here, the configuration here. So here in the see, I have given 59 seconds the timeout. My practice is 59 seconds. So storage also you have to see sometimes. Memory in the configuration, memory. Okay, storage, memory is snap start. Then edit. You have to edit if you need to change the configuration, the timeout. You have to edit here. So my practice is 59. So you saw here the 59. Okay, guys. So this is the thing, the Lambda timeout. That means configuration. You have to go to the configuration. Then you have to change the timeout. Increase, actually, just increase. Use asynchronous invocation. Trigger the function asynchronously to avoid synchronous timeout limitations. You can do that, but from my best practice, just increase the time in the configuration. Optimize logic. Batch the instance stop request instead of stopping them one by one. Yes, you can do that. EC2 client stop instances, instance ID, list of instance IDs. You have to do that. Then scenario 7, changing the color. So troubleshooting slow application performance on AWS EC2. This is very much common question about, and it's burning question also. An application hosted on EC2 is experiencing slow response times. How would you troubleshoot and resolve this issue? Slow response time. Check EC2 metrics. Use CloudWatch to monitor CPU utilization, memory, and disk I/O. Identify resource bottlenecks. So EC2 metrics, you have to see first. The problem is slow, right? This is the thing, the problem. So this problem slow. You have to go first. CloudWatch, same thing, monitor CPU utilization and memory and disk I/O also. But my practice is vastly done with CPU utilization and memory. Then identify resource bottlenecks. Then analyze system logs. Sudo cat var log messages. Sudo cat var log nginx error.log. So this is the thing. Check network performance. Verify security group roles and network SLs. Ensure no high network latency. Verify security group first rules and network SLs. Then ensure no high network latencies. Then optimize application performance. Scale vertically by increasing instance size and enabling enhanced networking. Scale horizontally by setting up an auto scaling group. So vertically size, increase the vertically, which on the size. That means is from EC2 T2 micro to T2 medium. Increase the size. Then enable enhanced networking. Then horizontal is scaling and is the horizontal, that's scaling out, that means adding more EC2s like that. Use caching, Redis or memcached. Oh man, it's very much important. Oh my goodness. Caching too much problem, man. So if you use the Redis or memcached, super if your client wants like that. If you are owner of the application, okay, you can do that. If your client is the owner of the application, you have to ask them. Then enable gzip compression in Nginx or Apache. You can use the gzip compression. So actually the gzip compression you are doing, then it makes the lighter, smaller. That means the memory or CPU especially is it's taking the very smaller. So you can use this one. Okay, then scenario 8, RDS database connection error. Your application cannot connect to an RDS instance after deployment. How do you resolve it? Connection, too much problem sometimes. NS lookup, network, NS lookup, RDS endpoint. Network service lookup, NS lookup, telnet, also telnet. So connection is NS lookup, network service lookup, and also the telnet. These two things. Okay. Then verify security group. Ensure the security group allows inbound traffic from the application servers. Then the database configuration. So check the database username, password, and connection string. Then IAM role configuration. If you're using the identity access management authentication, attach the appropriate IAM role to the application server. Scenario 9. One or more worker nodes in your EKS cluster are in a not ready state. So cluster node failure. So not ready state. How do you troubleshoot this? So check node status, kubectl get nodes first, then inspect kubectl describe node, then SSH into the node, check kubelet logs and Docker service status. So sudo journal ctl -u kubelet. So sudo systemctl status Docker. So kubelet, how to see, this is interesting and important also. Journal ctl -u, then kubelet. The possible solutions: restart the kubelet and Docker services, restart, right? Have to restart. Verify the node IAM role has the correct permission. See the permission. Then check for insufficient CPU or memory. So from the CloudWatch, you can see the insufficient CPU or memory. Then scenario 10. AWS auto scaling not triggering as expected. So your auto scaling group ASG is not scaling even under high load. How do you troubleshoot and fix it? Check CloudWatch alarms, ensure alarms are configured correctly, to trigger scaling actions. Verify scaling policies. Ensure policies are associated with the correct ASG. Then health check configuration. Ensure that the health check type is set correctly, EC2 or ELB. Instance lifecycle hook issue. Check for stuck lifecycle hooks and prevent scaling events. So this is the thing 1, 2, 3, 4. This is the checklist for auto scaling not triggered as expected. So you have to see this guys, health check especially you have to see. Then scenario 11, Terraform state file locking issue. Yes, so Terraform operations fail with a state file locked error. How to resolve this? Check lock in DynamoDB. If using remote state with DynamoDB, inspect the log table. AWS DynamoDB scan table name, then Terraform log table. Then manually remove log. AWS DynamoDB delete item, then table name, Terraform log table key log ID. Just keep in mind that log ID. Then this is the coming, that variable is coming. The best practices: enable DynamoDB state locking. Okay, you have to enable this is the, and avoid running current Terraform operations. The scenario 12, Jenkins agent connection failure. Jenkins agents are unable to connect to the Jenkins controller. How do you troubleshoot this? Interesting. So check the agent logs. That means EC2 logs. You have to see, analyze agent logs for connection errors. Then verify network connectivity. Ensure the security group allows inbound traffic to the controller on port 5000 like that. And Jenkins actually 8080 is really, but you can see also. Then node configuration. Verify that the agent is configured correctly with the Jenkins controller's IP address. Restart agent. Java jar agent.jr. Then this is coming this way. You have to restart Java jar agent like this. Then scenario 13. This is AWS Lambda cold start optimization. Your AWS Lambda function has a high cold start time. How do you optimize it? High cold start time. That means very slow, man. Okay. So use provision concurrency. Then pre-warm Lambda functions. Then optimize package size. Reduce the function package size to minimize initialization time. Keep warm mechanism. Use CloudWatch event roles to invoke the function periodically. Then code based practices. Avoid heavy initialization in the global scope. You can use that. Then scenario 14, Kubernetes ingress not routing traffic properly. Traffic is not being routed to your Kubernetes services via ingress. How do you resolve it? Very important, man. Check ingress configuration. kubectl describe ingress. So you have to describe the ingress name. Then verify ingress controller. Then ensure the ingress controller is deployed and running. DNS configuration. Verify that the domain resolves to the correct load balancer. Then TLS configuration. Check for proper certificate. So proper certificate, you have to check also certificate manager. So DNS configuration, resolve the domain, resolve the correct load balancer. That means you have to go to the A record in the route 53. So this is the thing for ingress. Then scenario 15, real-time CI/CD GitOps failure. GitOps deployment with Argo CD fails after a code push. Okay, how do you troubleshoot it? Check application status. argo cd app get, like this way. This is the command, man. Argo cd app get application name. Inspect sync logs, argo cd app logs. Okay, please memorize this, guys, because I cannot remember. So this is very much important. Resolve git merge conflict. So you have to resolve the git merge, sometime the conflict with the branches. Ensure the git repository has no merge conflict. You have to see if merge conflict, then this kinds of problems, which one, GitOps failure, argo cd, that after the code push is not cd, that means deployment is not done. So merge should be no conflict. Best practices: use automated validation script before merging code into the main branch. So this is the thing, you have to use the automated validation script before merging into the main branch. You have to do the validation, very much important. So if you do the automated, then that's good. So guys, these 15 real-time issues, actually scenarios, 6 questions with 15 scenarios, I think it will be helpful for you all. So yes, I'm coming with another, of course, very much important one. Till then, take care. Bye bye.